Introducing G-Core Managed Kubernetes, the ultimate solution for streamlined Kubernetes management. Experience support for bare metal nodes and a robust 99.9 uptime SLA at no extra cost. Easily provision Kubernetes clusters with a single click using our intuitive dashboard, API, or Terraform. Seamlessly integrate with G-Core external DNS and easily provision block volumes for your storage requirements. And of course, stay up to date with the latest Kubernetes versions. Plus, we have an exclusive offer for you. Click the link in the show notes and use the promo code CLOUDCAST and receive a £100 credit to try G-Core services today. Use the promo code CLOUDCAST and receive a $100 credit with G-Core services today.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And it is Aaron for Cloud News this week. But before we dig into Cloud News, two quick things. Number one, we have a fantastic guest coming up after Cloud News. You definitely want to stick around. We have Dr. Ronen Dar, co-founder and CTO over at Run AI, and we're going to be talking about building large AI models. And second of all, Cloud News this week, and as those that follow the show know, depending on the week, you get a little bit of funding rounds, you get a little bit of what's in the news, CNCF projects and the like. This week, there's a lot of AI articles. So definitely go check out the links in the show notes. There's some things in there about Llama 2. There's some things about tuning language foundation models in Google Cloud. There's talk of OpenAI, Google's, and others pledging to watermark content. So there's lots going on. But let's jump into our specific articles for this week. Number one, Tekton. Tekton, who, by the way, we have them scheduled to talk more in depth about all of this very soon, but they have the Applied Machine Learning report coming out. Actually, it just came out, sorry. And they have talked to over 1,700 respondents in the survey and lots of really good trends and key findings in there. 63.8% of respondents said their teams have at least one real-time ML model in production. That actually surprised me, the in production part. I know a lot of folks are out there, we're learning about this and dabbling and talking about inferencing and training, but hey, this is, actual things that are in production. So definitely, like I said, go check that out. And we're going to have them on the podcast to talk more about it specifically in a couple weeks. Number two, it was really interesting to me because probably we should have seen this one coming, but ChatGPT and the others, they're generating a lot of code. And actually, if you listen to the Software Defined Talk podcast, Brandon also talks specifically about how good it is at generating code sometimes. But Speakeasy is a new startup that is using AI to automate API creation and distribution as well. So they emerged from stealth with a $7.6 million seed investment. And that's definitely something I'm going to keep my eye on because I've been kind of following this intersection of APIs and security and automation as well. So just for me personally, this one's super interesting, and I'm looking forward to more out of Speakeasy and where this is going. And another report for Cloud News. And this one actually is a couple weeks old, and this is one I look forward to every year, talking about APIs, but I actually missed it. So this one came out the end of June. This is the 2023 State of the API report from Postman. And if you're familiar with it, it's one of the big reports, especially in the APIs and developer side of the house. Lots and lots of really good information in there, really good key findings, and lots of interesting trends year over year. So definitely go check that one out. And with that, I'm going to wrap up Cloud News for this week. Lots of reports to go for everyone to go look at. So y'all have some homework out there. But coming up after the break, we're going to be talking to Dr. Ronen Dar, co-founder and CTO at Run AI, about building large AI models.
Today's show is sponsored by Equinix. We all utilize multiple cloud providers, and we know they aren't built to work well together. Things get a whole lot more complex when your hybrid infrastructure needs to connect with your multi-cloud portfolio. Equinix is the world's digital infrastructure company, providing on-demand infrastructure in over 25 metros with hands-free provisioning and management, all connected to over 240 data centers and most major cloud providers. Equinix can help you deal with increasingly complex architectures, whether you want to run your favorite Kubernetes distribution or connect workloads between different cloud providers. To learn more, sign up at deploy.equinix.com and use the coupon code CLOUDCAST, CLOUDCAST, to get $500 in credits to get started today. That's deploy.equinix.com and use the coupon code CLOUDCAST and get those first $500 in credits today. Today's sponsor is Datadog, a real-time monitoring platform that unifies metrics, logs, and distributed traces from your cloud containers and orchestration software. Datadog's container-centric monitoring features allow you to track the health and performance of your dynamic container environment. The Container Map provides a bird's-eye view of your container fleet, and the Live Container View searches, groups, and filters your containers with any criteria, like tags, pods, or workspaces. To start monitoring your container clusters, sign up for a free trial today, and Datadog will send you a free t-shirt. Visit datadog.com/container-cloudcast to get started. That's datadog.com/container-cloudcast. And we're back. And folks, if you've been listening to the show any bit of time here over the last even weeks or months, you know that AI has been not only a persistent topic of the show, but one of the most popular, the most talked about, the most interested over the last 6 months in particular, especially since all of you are now sort of have access to the tools that are at the core of AI, whether it's something as simple as ChatGPT, or you're starting to play around with large language models, you're starting to build things for your companies. And one of the things that we kind of constantly get all the time is, I have a million questions about this. How do I size things? How do I figure out, how to build the applications, how to deal with infrastructure and so forth? And so what we're trying to do is make sure that we're covering AI from as many angles as possible. We're trying to get you access to as many experts in the field as possible, whether it's on the side of building models, whether it's on the side of making sure that you're properly using the infrastructure that you have for you. And so today, really, really excited to dive into trying to build large AI models. And so today, really excited to have Dr. Ronen Dar, who is co-founder and CTO of Run AI. Ronen, welcome to the show. Great to have you on.
Hey, Brian. Good to be here. Thank you for inviting me.
Absolutely. Where are you joining us from today?
So I'm in Tel Aviv. I'm speaking from our offices. We're based in Tel Aviv, and we have many people also in the US and in Europe. Right now, I'm in the US. I'm in Tel Aviv. Actually, tomorrow I'm going to be in the US. So I'm being both in Israel and the US, traveling between the countries.
Excellent, yeah. Excellent. Well, before we dive into Run AI too much and really kind of dive into this topic, give us a little bit of your background, both prior to starting Run AI, as well as what your focus is with the company these days.
Yeah, so my background before Run AI was mostly in the academia.
Okay.
I've been for many years here in Tel Aviv University. I did my bachelor degree, my master's, and my PhD here in Tel Aviv University. And my field of expertise was around information theory. So information theory is a field about how to measure information and how to create applications from information and using that. So a lot of my work was around learning systems and so on. And in the university, it's where I met my co-founder, Omri. So both of us, we had the same supervisor. We had a similar thesis. So we worked a lot back then. It was really fun, still fun to work together. And I did my postdoc afterwards. So I've been in the States for a few years. And during my postdoc, I actually attended a talk by Yann LeCun. So Yann LeCun is a professor in NYU. He's one of the fathers of deep learning and convolutional neural networks. And he's also managing AI at Meta, at Facebook. And he gave an amazing talk. It was back in 2015, and it was amazing. It was amazing. And I remember that I said to myself, okay, here in this space, I need to be. AI is amazing. There is amazing technology here, new one that will for sure change the world. And I knew that I wanted to be there. My co-founder Omri was he's like the common entrepreneur, the typical entrepreneur here in Israel. He was for many years in the army. So he got released. I finished my postdoc and I came back to Israel, and we started Run AI around 2018. And both of us knew that we want to be in the AI space. So we saw back then, it was in 2017, we saw that it's going to change the world, and we wanted, to be part of that revolution and just contribute our part. And we started then. The company was started officially in 2018. We raised money, and we started then. So 5 years we're running, and in my role here in Run AI, so I'm the CTO.
Yep.
And my role changed a lot during the 5 years. So in the first years, I think it was a lot about of course technology and product, and a lot about team building, right? So there are some amazing engineers here in Israel. So and we have quite a few of them here working with us in Run AI. So it was a lot about team building and about tracking, the technology and the product and finding that product market fit. And that was the first years. I think my role changed. Right now, I'm with my CTO hat. I have a group here in my CTO office. We're doing research. We're doing research on a few subjects. So one research that I'm doing is on GPUs. So at the CUDA level, how we can optimize usage and utilization of GPUs. So we're doing a lot of research around that, and we're doing a lot of research around LLMs and large models and how they can be trained in a simpler way, more efficient way. And the third bucket is around Kubernetes. So we're really all about cloud native. We've built our entire product on top internally. Like in Kubernetes, we're doing a lot of stuff on top of Kubernetes, in Kubernetes, on the internals of Kubernetes. So we're doing also a lot of research in Kubernetes, and we're doing also a lot of open source around those three buckets. So it's all coming from my CDO office group. And then, as with my founder hat, I'm also very close to the go-to-market, working with the marketing team, and trying. It's always scaling the go-to-market is always interesting, and you always need more. So it's always about scaling the go-to-market. So I'm also there very much.
Yeah, no, that's outstanding. It's I'm always fascinated, not only in companies' origin stories, but just as an individual. Sometimes, what was that specific moment that sparked your interest in something? What thing kind of lit that light bulb for you and said, no, this is where I should focus on. So I appreciate that story and that history. Today I want to dig into especially those three areas that you really talked about. Understanding how to maximize GPUs, how to do scaling, where this plugs into tools like Kubernetes. But before we start, I want to kind of start with maybe something a little broader. What you deal a lot with people that are building AI applications. You've done that previously in academia. You're doing it now with Run AI. What are some of those characteristics that make AI applications unique in terms of how they're going to interact with GPUs, with the systems that help schedule them? What sort of makes them unique that people need to be thinking about?
Okay, that's a big question. It's a great question. So AI applications are very different than traditional software applications. And I think the AI applications combine at a very high level three major aspects: data, compute, and algorithms. So to create an AI application, to create an AI model, you need, first of all, data. A model is like the algorithm, the way the model learns from data, and learns weights and learns how to predict and infer from new data after the training. So it's about algorithm, a lot of data, and also about compute. So compute is really important, as typically with the applications, you need to process a lot of data to get to some reasonable results and to be able to solve hard questions. So I think it started from 2012, 2013, around those years. That was the big breakthrough of deep learning in the industry, and it started with a few researchers from Toronto University who trained AlexNet. And that was the first model, and they were one of the first to show that with a new compute resources, with the new computer devices called GPUs, one can train bigger models faster. So there was a famous ImageNet competition that was open publicly. And in that competition, they showed that with GPUs, you can train a bigger model and get better accuracy. So back then, it was the big breakthrough of deep learning in the industry. People saw that you can train on GPUs and get amazingly better results than before, because you can train larger models on more data much faster. And so AI applications are really compute hungry. They are really compute intensive, and because they need to process a lot of data. So I think since 2012, 2013, we saw a trend of researchers building bigger models that are being trained on more data and are consuming more compute power. So if AlexNet in 2012 was trained on 2 GPUs, we saw afterwards in computer vision, like 5-6 years, that new models came out, and they were bigger and bigger and bigger, and they were trained on more and more models, on more and more data, and they produced better and better results, and the compute requirement just grew exponentially fast. So we saw like state-of-the-art models in computer vision being trained on hundreds of GPUs. So in 2017, 2018, there was a big breakthrough also in natural language processing, in NLP. So if the years before was about computer vision, since 2017, 2018, we see the same trend in language models. So an amazing paper came out in 2017, Attention is All You Need, with a new model, a new architecture of models, transformer models. And since then, researchers were able to train bigger models, build transformers on more and more data, and producing better and better results. And it started with Google getting out BERT, and it started with GPT-1 by OpenAI. And 5-6 years afterwards, right now we're seeing OpenAI training GPT-4 on more than 1,000 GPUs. That's the estimation. So we see really huge models with hundreds of billions of parameters being trained on the entire internet. So I think that trend of more compute, more data is amazing, and it's really unique for AI applications. And right now the industry is really there about training and providing that computing infrastructure, so companies will be able to train those models and also deploy them in production. So that's another challenge, how to run those models in production. It's totally different than regular software applications that are running in productions. Also, like those language models are really compute intensive, and they are running on GPUs. So running them in production is really complex, really difficult.
Yeah. I want to dig into the GPU aspect. Obviously, most of us who have been around the industry have run applications on CPUs. We worry about the number of cores and keeping up with sort of the Intel trend. When things move, when I don't want to say when they move from CPUs to GPUs, but when I'm building an application that's going to run on GPUs, what changes? What types of things do I have to think about differently? What's needed to get the most out of GPUs? Because obviously they're a more expensive resource to a certain extent. There's some scarcities of them. What are the core things I have to be thinking about to best take advantage of GPUs?
Yeah, so GPUs, it's really interesting. We love GPUs here in Run AI. So, NVIDIA, they are here for like almost 30 years. So GPUs are not new, right? So NVIDIA really succeeded in the gaming market with GPUs, but then they understood that with GPUs you can also do linear processing and accelerate linear processing significantly. And deep learning and AI is really it's really a lot about linear processing. So you can accelerate deep learning applications with GPUs. So in that sense, GPUs are relatively new in the data center when it comes to AI, right? AI is also right new in the data center. So it comes with new requirements, and I think that there are some significant challenges right now when it comes to GPUs, and we see it in the market right now, both when it comes to companies training models, and also when it comes to companies deploying models and running them in production, doing inference, right? And I think in training, it starts from the fact that with data science teams and AI teams, they are different than software developers, right? So data scientists are more scientists, right?
Right.
They're not coming from engineering background, and for them the AI work is really about experimentation. So researchers, data scientists, ML engineers, right? They would run an experiment, right? They will train a model, and they will get some results on the accuracy of the model, for example. But then they will change things in their experimentation, and they will try again and see what the results are. So they will change the way they augment the data, or they will change the parameters of the model, like they will change the batch size or the learning rate, and they will try again. So it's really about try and error, and about experimentation and running another experiment and seeing what is working and what is not working. So when you have a way of working like that, and you're experimenting with compute like GPUs, which is really, really expensive, right? When you spin up one GPU machine in the cloud, the newest one, I think it's like more than $30 per hour, just spinning up one machine. So that's a lot of money. $30, more than $30 an hour. So you spin up those really powerful machines, which are really expensive, and they are also really scarce because they are so expensive. So getting access to those GPUs is sometimes really difficult. And when you're doing that and you're experimenting, and you as a data scientist want to experiment fast, so that becomes difficult, because when you're experimenting, just running one experiment is really difficult, because for 90% of your time, you need to deal with infrastructure challenges. You need to deal with installing. If you don't have any solution for your infrastructure, you need to deal with installing drivers on your GPUs and installing libraries, and setting up your Jupyter notebook and opening ports and doing a lot of stuff relating to infrastructure, that only then you start to experiment. And if you want to, as a data scientist, if you want to scale out or up your experiments, if you want to do like 10 experiments in parallel, that's really difficult for you. You'll need to do what you did for one experiment 10 times with a lot of manual work. Or if you want to scale up one experiment and run it instead of one GPU, you suddenly want to train it on much more data, and you want to scale it to 8 GPUs or scale it to tens of GPUs or hundreds of GPUs. That becomes really, really, really challenging, and you will need to work on it like for months. So so when infrastructure is not there, and with GPUs, it's really difficult to get access to them and really utilize them efficiently, then it really hurts the productivity of the data scientist and the pace of which they can iterate and experiment. And so data science, so the way that traditionally organizations are giving access to resources is traditionally by quotas, by static quotas. But the problem with static quotas is that that data scientists sometimes need just one GPU to run their Jupyter notebook on, but some weeks they might need tens of GPUs to run multiple experiments or to run just one big job. And then weeks they can be idle and not utilize their GPU. So with quotas, it's really difficult to give efficient access, because either you give too little and the data scientist can experiment fast enough, or you're giving too much and then it becomes idle. So for what we see is really like resource management is a critical part, and really providing access and managing quotas on GPUs is really difficult. And it comes up, the result is that data scientists are very much progressing in a slow pace, because it's really hard to experiment. But also from the infrastructure level, you see typically, and what we see is low utilization. You see a lot of idle GPUs because it's really difficult to just allocate them efficiently.
Yeah, and it seems like it's a little bit like, and you can probably appreciate this. Some of the younger listeners may not, but you know, back in the days when you had things like mainframes or even like shared, university computers, you almost had to timeshare stuff. You had to schedule time to be on it, and it forces, it seems like it's forcing people to unfortunately get back to the thing of, well, you want to experiment, but you also have to have all of your ideas at that time, not whenever you want to, like the rest of the way cloud computing works, which is, on demand. You might work at night, you might work in the morning.
Exactly. Exactly. So something got broken in that way of working in the cloud in an on-demand fashion, because it becomes really difficult when you're experimenting on the resources, and the resources are really, really scarce and expensive, and it's really difficult to allocate them in an efficient way. Yeah. So that's the problem that we see, and it results in really low utilization, idle GPUs, and at the end, data scientists that are it's difficult for them to iterate fast.
Yeah.
So that's on the training side. On the inference side, it's also really interesting. In the inference side, I think now with large models, with large language models, we see for the first time that a really huge jump in the computing requirements for inference. So if until now models were usually being run on CPUs or on one GPU or like fractions of a GPU, now we see huge models with hundreds of billions of parameters, and they need to run on 4 GPUs or 8 GPUs because they don't fit into the memory of just a single GPU. So then it becomes really difficult, right? You need to run just one model on very expensive GPUs, and I think that's one of the problems when you're deploying language models right now. Inference becomes a huge problem. We're hearing, Sam Altman, OpenAI CEO, speaking about the compute costs and how eye-watering they are. So it really comes in inference. It's a huge problem to utilize efficiently GPUs, and that's a huge problem as well.
Yeah. One of the things Run AI does, you're focused on trying to help optimize, the scheduling of those environments, right? So you do work essentially on top of Kubernetes. Talk us through, kind of because a lot of people these days are using Kubernetes for a lot of applications. AI is one that's talked about as well. It's cloud native. That's the modern environment. Talk a little bit about maybe where Kubernetes falls short or, can't be as efficient as you need to, and then what you guys do to help optimize that.
Yeah. So Kubernetes is an amazing piece of technology. Really, it changed the world of the infrastructure world, right? And we have quite a lot of Kubernetes engineers here at Run AI. We love Kubernetes. And Kubernetes is amazing, but it was built for running microservices, right, on CPUs, on commodity CPUs in the cloud. And now, as we spoke, right, AI applications are very different. They are very compute intensive, and they run on GPUs, totally different. And what we saw is that just in terms of scheduling, what Kubernetes provides and doesn't fit what AI workloads and AI teams need. So we spoke about the need to experiment fast, and we spoke about the need of like hard quotas and how limiting it can be and how inefficient it can be. And so we've built a scheduler, a Kubernetes-based scheduler that can run on any Kubernetes platform. And we brought scheduling concepts from the world of high-performance computing. HPC is a world where also you have very compute-intensive workloads, and also scheduling is really complex. And we brought concepts from there. We brought concepts from machine learning, from Hadoop, from Yarn. Yarn is an amazing scheduler, so we took concepts from there. And we brought these concepts of a few things. We brought concepts around quota. So we brought a concept of guaranteed quota. So each team, each researchers with Run AI could get a guaranteed quota for GPUs that will always be available for them. But it's not a hard quota. It's a soft quota, and they can always go above their quota and use essentially any GPU available in a shared cluster. So any GPU which is idle, they can essentially use it, and so they can experiment at much larger scale. So they can get access to any GPU on demand, and our scheduler manages everything, and they can run it on hundreds of GPUs. So we have customers running with thousands of GPUs in one cluster, and they are all sharing. There are like a lot of data scientists sharing the resources, running workloads on hundreds of GPUs. And that's one workload. So we brought brought a scheduler. And the second thing that we're doing is also around GPUs and GPU virtualization. So we also saw that with GPUs, getting access to GPUs is very static and fixed. And we saw that it's really difficult in Kubernetes and in general, actually, to fractionalize GPUs, to share GPUs more efficiently. So we built we call it like an API level virtualization, or a CUDA level virtualization. So we sit at the CUDA level, and we intercept CUDA calls, and we manage the access to the GPUs. So essentially, multiple workloads can get access to a single GPU to share it. And so we're fractionalizing GPUs. We know how to swap memory between GPU and CPU. So we can essentially do a lot of over provisioning of GPUs. And that makes a lot of sense when you're running inference workloads, right? And so we have customers where we help them to reduce inference cost by 10x, really providing a lot of efficiency when it comes to production environment. So that's the second thing that we've built. And we're still building, we're still doing a lot of research around those things. And we wrapped everything in a product, and we're providing tools for a data scientist to train their models very easily, to deploy their models very easily. So we abstract a lot of the complexity there. We're providing tools for IT teams to manage infrastructure, to provide quotas, to monitor, and so on.
Interesting. Obviously, for a lot of people right now, AI it becomes synonymous with this idea of large language models. Obviously, there's lots of different AIs, but LLMs are kind of top of mind for a lot of people. How much, if somebody is talking to their infrastructure team, or they're planning some of this, they're going to bring this into their applications. Like, how much bigger are there considerable differences between sort of the large language models we hear about, number of objects as part of them in the billions. Are they significantly bigger than sort of the AI models of the past or the AI data centers, data sets of the past? I know you talked about that a little bit at the beginning, but can you give us some sense of, relative how much bigger they are, or, what somebody might expect as they start, going down this path?
Yeah, that's a great question. So I think when it comes to computer vision applications, and the first wave of AI, like a recent AI in the industry, was about computer vision, right? We saw the breakthrough of autonomous cars resulting from that, technology breakthrough of being able to analyze pictures and videos with machines, right? So computer vision's models, a lot of work has been done on just running them efficiently in production, and also at the edge, right? All of us have, in new cars, you have a lot of AI running inside of the car. So in that sense, you're getting models, but you're getting models that are, not that big when you compare it to language model. So as I said before, with NLP in language model, the numbers are much, much, much bigger. So the new models, right, GPT models, the largest models, they can have hundreds of billions of parameters, right? So the number of parameters is an indication for the capacity of the model and how capable the model is, and how generic the model is. And so language models with hundreds of billions of parameters, those are like the state-of-the-art GPT models. I think right now at the open source language models, they are around a few billions of parameters or tens of billions of parameters. People are right now evaluating those models, and a lot of work has been done on that. And people showed that language models with a few billions of parameters or a few tens of billions of parameters can perform well, like GPT models with hundreds of billions of parameters. But it's not that real. So I think there is a lot of study going on right now on what should be the right size of language model. I think right now it's the scaling is somewhat, I don't want to say over, but we saw in the last few years really an exponential scale of the size of those models. But I'm not sure that it will continue. Language model won't continue to grow as much. So we're speaking about models like from a few billions of parameters to a few hundreds of parameters. So the rule of thumb in terms of how much memory, for example, each model consumes, so it's relatively a factor of 2. So if you have a language model with 10 billions of parameters, it will consume around 20 gigabyte of memory.
Okay.
So you can see like new GPUs, the A100, the H100, they come with 80 gigabyte of GPU memory. So when you're speaking about like 10 billion parameters, so it fits into one GPU. You can actually fit multiple models like that on one GPU. But when it comes to a model with 100 billion of parameters, then it doesn't fit into the memory of one GPU, and then you need a few of them, and then it becomes much, much more challenging.
Yeah, no, it makes sense. I want to ask you one last question. I know you're a very busy man these days. If you and this may be way beyond sort of your scope and your purview, but we've talked a little bit today about some of the scarcity of GPUs and so forth. Have you found any good strategies or any good tips for people that are saying, look, we're we're finding value in these AI applications we're building. We're wanting to do experiments, but we're running into, limitations. Any suggestions for that, or is this just one of the cycles in our industry in which, say, the supply chain has to catch up to the demand? Are there things that people can do, or any suggestions?
Oh, that's really, really an interesting topic, right? The GPU shortage. So, right, when OpenAI published ChatGPT and it just exploded, right? OpenAI showed to the entire world what can be done with LLMs, and it exploded. And I think once it happened, a lot of companies saw these new capabilities. A lot of companies right now understand that there is a new technology here that is going to transform every industry. And now everyone understands that they need to figure out how they can use AI and how their industry is going to change following this technology. So in the last 6 months, we saw a huge demand for GPUs. Everyone wants to build AI models to run them in production and use them on GPUs. So the demand for GPUs just got exploded. We saw Nvidia's stock skyrocketing in the last 6 months, and so the demand right now is much higher. The demand for GPUs is much higher than the supply. It will catch up, of course.
Sure.
But my prediction is that it's not the last time that we're going to see the demand for GPUs increasing much more than the supply can provide. So getting access to GPUs is a problem right now, and it will become more and more of a problem. It's really important for companies. Companies look at right now at infrastructure and AI infrastructure as a strategic thing, and compute and building the right infrastructure, the right compute for your AI is a challenge. I think it doesn't matter if you work on premises or in the cloud. So securing access to GPUs is really important. And for me, I think the recommendation is to look ahead for companies. To first of all, to look ahead and start experimenting with AI. And if they haven't found a use case for AI, then start doing it. Start look for use cases in your organization, in your industry for AI. Start AI initiatives in your organization, and take infrastructure into account, because it's really important. It's the basis of your AI. It will become more and more important.
Absolutely. Dr. Ronen Darth, thank you so much for all of the time today. I know we dove into a lot of different topics, but this was really helpful to give us a really good broad perspective on not only the challenges that people are having with this new space, especially as it's becoming more widespread, but also some of the ways in which not only they can better utilize the resources, but how they should be thinking about this in the bigger picture of things. So thank you so much for some of the time today. Folks, we will include a number of things in the show notes for how to engage with the Run AI team, how to dig into more of what they do, especially if you're working in Kubernetes environments, if you are beginning to think about this both from, as Dr. Darth said, both the infrastructure as well as the models and so forth. So Dr. Darth, thank you again for the time today. Thank you for helping educate the audience. And folks, with that, we want to wrap it up for today. We want to thank you all for listening. We want to thank you for telling a friend about the show, for helping us grow the community. And with that, I'm going to wrap it up, and we'll talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.